We're back with section 2-5 continued, the second part of solving proportions. What do we use all these proportions for? That's really the key. Proportions are so important because we use them for a lot of things, including scale drawings and scale models when it's inconvenient to have things at full size. We either want to make a bigger picture of it, of things that are tiny, or a smaller picture of things or model of things that are huge. So scale is the ratio between two sets of measurements. Like 1 inch is equal to 5 miles, or things like that. And scale drawings and scale models, right, actually use that scale to represent an object smaller or larger than the actual. If you need more time with the definitions that you need to write down on page 26 of your notes, go ahead and pause the video. Anytime that you see scale written without units, it just means that that they have the same units, right? And it could be anything. So like in this example, 32 to 1, 32 feet is to 1 foot, 32 inches is to 1 inch. It doesn't matter. They're the same units on both. Here we have a really good example of a scale drawing. This is a piece of a blueprint of a hospital. Right? And obviously the hospital building is a lot bigger than what you see on the screen, right? So I don't know exactly what the scale is here because I managed to cut that part off, right? But inches on the drawing would represent feet, most likely, in the actual. Here's a kind of a simple problem we have using scale on a map. The actual distance between North Chicago and Waukegan is 4 miles. What is the distance between these two locations on the map? So very small over here and kind of blurry. It says 1 inch is equal to 18 miles. So here's they've rewritten it for us, 1 inch equals 18 miles. I really like to put the units with it because then I find it easier to set up my proportion. And we know that the distance on the map is 4 inches. See now, inches and inches are both on the top, so it's easy for me to keep the units that are the same lined up together. You don't want to get your proportion flipped upside down. And that means we're looking, right, for the actual distance, right, between these two. So we're just going to cross multiply, and 1 times x is just x, and 18 times 4 is 72. Put that label on it, word problem, word answer. So the actual distance between them is 72 miles. Going the other to another example here, this time about a blueprint. Contractor has a blueprint for a house drawn to the scale 1 inch to 3 feet. A wall on the blueprint is 6.5 inches long. How long is the actual wall? So very similar to the map problem. So we know that the blueprint's got 1 inch to 3 feet, and our wall is 6.5 inches long on the blueprint and x feet long in actuality. So cross multiply, and we get x equals 6.5 times 3. Well, 6 times 3 is 18, and half times 3 is 1.5. So add those together. That's 19.5 feet long. That's a pretty long wall. I did want you to write these examples down. I don't think I said that though. So if you need to go back now and write them down on the bottom of page 27, go ahead and stop, rewind, write both of those examples down, the one about the map and this one about the blueprint. Whoa, crazy board, hold on. Okay, now we're in the right spot. Another really common use for proportions is percents, and you're going to write this vocabulary down. It's there in the middle of page 26. A percent. You guys have done tons with percents last year, especially I think if you had Mr. Olson. He really pounded percents into you. So a percent is a ratio that compares a number to 100. Right? We can simplify them, but I always start with them out of 100. And you can use that proportion part to whole, equals the percent over 100 to find any unknown values. And some of you also learned the idea of is over of equals percent over 100 as a little mnemonic device, a way to remember it, because the is number is the part and the of number is the whole. Right? And then we always keep that 100 on the bottom. So let's try one here. Find 30% of 80. So there's our of 80. That's the whole, right, down here. Right? And we know the percent, 30%, right? So we put that over 100. And then we're looking for the part. Back to usual solving of proportions. Okay? So 100x equals 2,400. And divide both sides by 100. And remember, anytime you divide with zeros at the end, right, any zeros that are in common, you can just get rid of those, and we're left with 24 over 1. So 24 is 30% of 80. Now, some of you might have said, well, wait a second, why should I bother keeping that percent so big? Why couldn't I just reduce that already to 3/10? Sure, you betcha. Right? You can go ahead and reduce that, and then you get 10x equals 240, and so x equals 24. It doesn't change the answer, but it might make it a little simpler for you. $230 is what percent of 200? So the first thing to recognize here is that the part is actually bigger than the whole, so we should get a number bigger than 100%. Right? It's an increase of something here, maybe like kids at a school compared to how many there were last year, right? This year there's 230. Last year there were 200. So the part, even though it's bigger, goes on the top, right? And that's because, remember, it's the one that goes with the is. And 200 was the of. And we don't know the percent. You can use x, or you can use p, or you can use r. R is probably the most common in terms of the math circles, but a lot of people just like to use x. And once again, if you want to make your life a little bit easier, you could simplify this fraction here. So instead of having 230 over 200, we just have 23 over 20. And now when I cross multiply, that gives me 2,300 equals 20x. And I can divide both sides by 20. And I'm going to get rid of the zeros at the end there. So 230 divided by 2 would be 115. And don't forget that percent sign, right? 115% equals x. Definitely have that written down on page 27 along with the previous one. I do keep reminding you specifically to write those examples down, but you should be getting the swing of it. I want the examples in your notes. I think that might actually be it. And it is. So part 2 is pretty short. Go ahead and close up those notes.